Today I'm going to discuss with you 7.1 through 7.3, and that is confidence intervals for a mean and a proportion. We're first going to look at the confidence interval for proportion. A proportion is usually things like a political poll, number of people who would vote for a certain candidate, or number of people who would support some type of ballot initiative. A confidence interval allows us to predict election results, is the main use for that. We have a margin of error, and the margin of error is determined by your alpha, which is your confidence level, also the sample size. This allows us to create a margin of error, and we can predict where we think the election results will fall with a relatively good degree of certainty. The formula for this is on page 348, and that is the confidence interval for proportion. You can also find the required sample size on page 351 of your textbook, and this goes through the formula for finding the number needed for a certain sample size. It can either be done with an estimate for p-hat, or your point estimate, or without one. So it depends upon if we kind of know what it should look like for the results, or if we have no clue. Either way, you can get a rough idea of where your sample size should be. You can also use the confidence interval for a mean. And the confidence interval for a mean is on page 360. Very similarly to proportion, you have a margin of error, a degree of confidence, your alpha, and you also have a sample size n. We can use those along with our x bar, which is our estimate for the mean, and also our standard deviation sigma, and we can create a confidence interval. This would be things like a manufacturing plant. You can predict where the weight of a cereal box should fall if it's full of cereal. And you can use this to determine, is this machine making too many boxes that aren't within range? Some boxes are going to be filled more than others. If you fill up a box of cereal, you're going to have a certain amount of air and a certain amount of product. You want to make sure that it's pretty close to being the same. And you can use this to determine where the boxes of cereal should lie, where their weight should fall, and if they're too heavy or if they're not heavy enough. You could use this to then predict and see if the machine's working correctly. And we'll discuss more about that in the next chapter when you do hypothesis testing, which allows us to make decisions. But you can get an idea of where it should fall weight-wise. And you don't want to put in too much cereal and also not enough. So manufacturing facilities use this for quality control. Again, you can find the required sample size on page 364. And there is a formula for that that involves your standard deviation sigma, your your margin of error E, and also your degree of confidence, your alpha. That concludes 7.1 through 7.4.